Hello everyone, welcome back to another TouchDesigner tutorial. It's Yuvi here. I hope you're all doing good. So in this tutorial I'm going to show you the FLOW3D, which is a real-time fluid and smoke simulation. The simulation is all packed onto this component, and basically I'm rendering the output with my volumetric geo, which you can find on my Patreon also. It's basically a volumetric ray marching that renders the density or the any volume onto the render top. So yeah, the FLOW3D basically operates on 3D textures. It has some density field and velocity field and temperature field, and they're all affecting the smoke or the fluid. First of all, we have our simulation resolution or in our density resolution. So if you don't have a strong GPU, I don't recommend you to increase it that much. The default, it's like if I reset all the parameters, so the default it's 120 for the simulation on and density resolution, but you can go higher if your computer can handle this. So you can go higher only in the density resolution, but keep the simulation resolution lower, and you can go higher with both of them. But important thing is that there the density doesn't need to basically be the same resolution as the simulation resolution. Simulation resolution can get lower. Obviously it will affect the way the simulation works, but the density, it's the output itself which we are rendering, so this needs to be quite high if you want to have nice looking smoke, and the simulation resolution needs to be high if you want the smoke to feel like more like a smoke or to have more detail. So the default is just like kind of this injection of smoke or density that is moving around the simulation. You can not inject if you don't want, and if you reset, there's not gonna be any injection, and if you toggle it on, you can see the injection. I can also reset it with the keyboard in chop. Let's reset here the whole simulation and also reload the obstacle that I will show you later. So if I press 1, I can reset. Here you can change the force amount of the injection. So you can see this is less force, this is more force. You can go like very extreme maybe to see the effect. You can change the scale, make it bigger. The color, and the heat, which I will also show you in a minute. Generally, you can change also, of course, the position and make more injections by controlling those 4 inputs. So for example, for the position, I can just use a noise stop, not make it not monochrome, and let's say I want like 3 injections. Don't go crazy with this. I will keep it low. You don't need a lot of injections, it's really gonna be heavy on your CPU. Yeah, let's make it like 3, and we can connect it to the first input, and I want to limit it between 0 and 1 because this is the size of the simulation. Actually, I can make it zigzag, and let's animate it. Let's choose a simple 4D and animate the 4th dimension. Now you can see we have 3 of them. Let's lower the size so you can see them both, all of them. All right, so this is for the position, and obviously you can do the same for the color. So let's copy the noise, and you need them to be the same resolution, obviously. Let's not animate the noise and drag it to the second input, and you have colors. And you can change it, and you can do the same for the size and for the heat. All right, so let's unplug those to see default, because I want to talk about those settings. So we have the resolution that we talked about, the velocities dissipation controls them, how fast the velocity will dissipate, basically. So for example, if it's very high, you can see it's dissipating very fast. We have the vorticity. So without vorticity, looks like this. With vorticity, you can see there's a bit more swirls and stuff like this. There's viscosity. So without any viscosity, you can see more of the vorticity also, because viscosity is essentially a blur. So it's blurring or averaging out the velocity. Let's increase the size a bit, maybe. We have the density dissipation, which controls the how fast the density will dissipate. So if I make it lower, it will dissipate slower. And if I make it high, you can see it's dissipating much faster. We have the pressure iterations. So don't go crazy with this. It's basically also affecting your FPS, but this is also making the simulation more realistic in a way, but also increasing the lowering the FPS. So maybe you can go lower with the simulation resolution, let's say, uh, and higher with the pressure, like very high, let's say. um, yeah. So yeah, a lot of stuff to play around with. So I will keep it like a two or three, maybe, not more. Obviously, you can make it 1 also, and it will work. I like to go high with the resolution because I can. All right, so We have also gravity. So you can see the smoke is falling to the ground slowly. You can increase also the gas weight to make it stronger. Maybe more gravity. We have the fluid surface level. So this is how the gravity will affect on the y-axis. So if you raise it, you can see that it's affecting only on the half of the y-axis. So for example, and if I increase it to 0, it will affect the whole volume. We have also buoyancy, which basically it's the kind of the opposite of gravity, and it's based on the heat. So we have here the uniform heat. So if I increase it, there will be more buoyancy, and also the cooling rate and the ambient temperature. So the difference between the ambient temperature and the heat will increase the buoyancy, and also if you increase the cooling rate, it will also affect. So buoyancy, it's the opposite of gravity. The direction is to the positive of the y-axis. Maybe to see it better, I can stop injecting and add a volume source. So for that, I'm going to use the T3D toolkit by Joseph Feltz. You can grab it here from his Patreon. It's a really nice toolkit and really, really useful for creating volumes and rendering it also. So I've just put the talks file of the toolkit onto my project, and I can now grab anything from the T3D operators. So for example, a sphere, and I want the same resolution, so going to reference it, choose 16-bit float, and connect it into the volume source. Right, so our sphere is too big. Let's decrease it, the radius. Now you can see the buoyancy much more clear. Another nice thing that we can do is add some obstacles. So let's add a box from the T3D. Also, I want to reference the density, the resolution, and 16-bit float. And we have the last input is the obstacle. Now I need to make it a bit smaller, and we can show our obstacle like here. And the obstacles are not currently in real time, so we have to cache them over here, because if I don't cache them, you can see the FPS will basically be very, very low. So just cache the obstacle, and each time you change, you need to reset or reload it. So I want to just like make it something like this and reset. Maybe make it a bit like this and reset. Cool. So yeah, this is the obstacles. Another cool stuff we can do with the T3D toolkit is to basically take any sub. So I'm going to grab the teapot from the examples. So file in and choose the teapot. And I want to get rid of the plane over here, so I'm going to use a delete sub. Delete by points, bounding volume, increase the size, and reduce the size of the y-axis until I get rid of the plane. Yeah, something like this. So now we can use the sub 2, make the resolution higher, get bounds, fill it, and lock it. So when we lock it, it's basically not cooking anymore, which is nice because we're not gonna change it either way. Let's add a null so we can see that our resolution here, it's a bit weird because it's getting basically calculating from the bounds of the from the sub, I believe. So we need to make a fit and fit it into our density resolution. And now we're good. So I want, instead of the sphere, to make the teapot as a volume source. I don't want any buoyancy for now, and I'm going to just connect it over here. I think we want to transform it also and scale it, so let's scale it a bit, make it a bit higher like this. Maybe make our obstacle a bit down, and yeah, something like this. I think it's nice. And I want gravity, and I want also the gas weight. So now we have a nice teapot, smoky teapot. Maybe more. All right. The last input that we have here is a external velocity. So let's change back to the sphere and get rid of the box over here of the obstacle. Let's make the sphere in the center. And I don't want any forces like gravity or something, or gas weight. I don't want also. And what I want is to add a noise from the T3D, not monochrome. I want the same resolution, 16-bit float, and from 0 to 1 like this, and connect it over here. So now we have like a velocity from that noise. You can change it, obviously. You can make it stronger. Maybe this is too much strong. And you can introduce also some gravity with the velocity itself. So yeah, just get wild with this and try to see the effect. Okay, let's disconnect everything, and I want to inject the default and to show you also how to render it with the volume from the T3D toolkit. So let's grab the volume and let's turn off the volumetric geo and just connect the density to the volume. And you can see we have our smoke rendered with the volume of the T3D. A nice thing you can do is connect a constant over here, and in the output make it maximum and lower the alpha to like 0.01 maybe, and then you can see the bounding box, which is really nice. Also, you can add a light that is a cone light and add a null and drag it to the lookup, so you will have a nice lighting. Only like in on parts of the oops, sorry, something like this. Maybe let's increase a bit the dimmer. Yeah, so it's actually really flattering the smoke, the volume of the T3D. I think also like changing the light color, um, and maybe changing the color of the density. Maybe, yeah, something like this. All right, really nice lighting on this volume T3D. Yeah, I think this is the end of this tutorial. I will upload the FLOW3D to my Patreon, so you can grab it from there. I really hope you will find it useful, and if you have any questions or problems, please let me know. Or also, if you have more suggestions of how to basically improve it, I would really like to know. I hope you enjoyed this tutorial, and see you in the next one. Thank you so much. Bye bye.